Good day, students. In this clip, we're going to be going over 4 examples on how to simplify radicals. So let's go ahead and take a look at question number 1. All right, the instructions are for us to simplify the following radicals. So let's write that down. I'll simplify the following radicals. All right, so for problem 1, we have the square root of 75x to the third power. Alright, so let's go ahead and find the square root. So to do this, we're going to break down 75 completely. So remember the rule, when you take in the square root, any two identical factors that appear can be rooted and they will come out as just one factor. Okay, so let's do the factor tree. You can do it over here. I'm just going to be extracting only primes, okay? So if I take a look at 75, since it ends in a 5, I know that 5 goes into it. So 5 goes into 75 15 times, 15x to the third. All right, let's go ahead and break down 15 further. Ends in a 5, so I can take out 5 times 3, and then times x times x times x. Okay, so any factor that repeats comes out as 1, any pair. So you see that the 5's repeat here. So if I group these two 5's together, that's 5 squared root of 25, and the square root of 5 squared root of 25 is 5, so it comes out of the square root symbol as 1 as 5. Okay, and then these two x's are x squared. If you take the square root of x squared, you're just going to have x. So these two x's are going to come out of the radical as x also. Alright, so 3, square root of 3 is just square root of 3, and square root of x is just square root of x. These two that do not have any partner to break out with will remain in the radical. Okay, so our answer to the square root of 75x to the third is going to be 5 times x. Whatever numbers or terms break out of the radical because of their repetition in the factorization, you multiply all of them together. So 5 times x is 5x. And left behind is 3 times x. Multiply whatever you have left behind inside the radical. Alright, so the final answer is 5x root 3x. So there you have it. Okay, let's take a look at question number 2. Question 2, we have to find the radical, simplify the radical root 72. Okay, so we're going to use the same procedure here. Decompose 72 completely. Any factors that repeat, we will extract, okay? So this is an even number, so I know 2 goes into every even number. 2 goes into 72, 2 goes into 7, 3, and 12, 36. All right, so let's break down 36. This is even, so I can take out a 2. 2 goes into 36, 18 times. Take out another 2 from 18, 9 times. And then 3 times 3. Okay, another way we could have done this is we'll look at 36, and then if you identify the fact that this is a perfect square, you can just break it down into 6 and 6, and those two sixes will come out as 1. All right. I just wanted to follow the same procedure that I outlined in part 1, which is to decompose a number completely and extract factors that repeat. Whichever way you do it, you still end up with the same answer. Okay. So these two 2's are identical. 2 times 2 is 4, and we know what the square root of 4 is. It's 2, right? So if I group these two and I root them, I'm going to end up with a 2. And then 3 and 3, 3 times 3 is 9, and we know what the square root of 9 is. That's 3. So these two 3's, 3 times 3 will come out of the radical as a 3. Okay? The other 2, this is by itself, so it remains under the radical sign. All right, so the simplified form of this is going to be 2 times 3, the numbers that had pairs, and then the 3 stays behind, the 2 stays behind. And then 2 times 3 on the outside is going to be 6. 6 root 2 is your simplified form of the square root of 72. All right, let's go ahead and take a look at question number 4. I'm going to do it on this, question number 3. I'm going to do it on the side right here, question 3. Still the same procedure. We are we're simplifying radical expressions, okay? So for question 3, we have 3 divided by the square root of 48. Let's write that down. 3 divided by the square root of 48. Now, when you're dealing with radical expressions, you are not permitted to have radical in the denominator, okay? So that's the situation here. So to address this problem, you are going to carry out a process called rationalization. You have to rationalize the denominator. How do you do that? Whatever the radical term is in the denominator, you multiply the numerator and the denominator by that value. So root 48 and root 48. Okay? So this becomes 3 root 48 over root 48 square. When you square a square root, you have an inverse operation happening there. So square root is the inverse of square, so these two cancel out. And then you're going to be left with 3 root 48 over 48. Now let's focus our attention on this 48 right here, and let's simplify it as much as we can. So extracting the 48, we're going to break it down into prime factors, and then whichever pair repeats, it will come out of the radical as 1. Okay? So I can take out a 2 from 48 since this is an even number. I'm left with 24. Take out a 2 from 24. Left with 12. Take out a 2 from 12. I'm left with 6. Take out a 2 from 6. And I'm left with 3. Okay, so 2 times 6, 2 times 3 is 6. Alright, so there you have it. Now let's see which pairs break out. These two 2's repeat. So these two 2's break out as a 2. These two 2's repeat also. So they break out as a 2. So root 48, this 3 stays behind since it doesn't have a pair to break out with. So root 48 is going to be 4 times the square root of 3. Okay, now we're going to insert that back into the numerator here. So we're going to have 3 times 4 root 3 divided by 48. If we multiply that out, we're going to have 12 root 3 over 48. Okay, so the question is, are we done? Can it be simplified further? And the answer is absolutely. We can simplify this because we know that 12 goes into 48. You can see it here. 12 is a factor of 48. So the GCF of 12 and 48 is 12. So we'll divide the numerator and the denominator by that value. Divide by 12, divide by 12. And then your final answer is going to be the square root of 3 divided by 4. Okay, so that's the simplified form of 3 over the square root of 48. Okay, so there you have it. Okay, let's shift our attention to the last problem, problem number 4. So for problem 4, we have to deal with the simplification of a radical fraction, which is root 128 over 63. All right, now in this situation, you remember initially I stated that in number 3 that you cannot have a radical in the denominator. Also, your radicand cannot be a fraction. This is another type of violation when you're dealing with radical terms. You cannot have a fraction as a radicand. Radicand is the term under the square root, okay? And as you can see here, the term under the square root is a fraction, which is unacceptable. So let's go ahead and reduce it. So what we're going to do is we're going to separate the radical into the numerator and the denominator. So it's going to be the square root of 128 divided by the square root of 63. Okay? Now we do not have, the radicands are no longer fractions, but we left one violation and ended up in another violation. The violation here is that you have a radical in the denominator, and that's not acceptable. So to address that, you're going to have to rationalize the denominator. You multiply the numerator and the denominator by the square root of the by the radical term in the denominator. That's known as rationalization. Alright, so now we're going to multiply across, okay? Let's go ahead and multiply across. If we multiply across, we're going to have the square root in the numerator of 8,064, and in the denominator is going to be the square root of 63 squared, which is just 63. Okay, now what we're going to do next is decompose 8,064 completely and see what factors repeat so we can extract them from the radicand, okay? So since this is even, I can take out a 2. If I take out a 2 from that, I'll have 4,032. Take out another 2. I'll be left with 2,016. Take out another 2. I'll be left with 1,008. Can extract another 2. I'll be left with 504. Getting a little bit long here. Keep on going. So take out another 2 since it's still even, and take out a 2. I'll be left with 50 goes, 2 goes in it, 50, 25 times 251. Alright, let's see what we can take out. How about we take out, can 3 go into this term? Is the question. Alright, I think I made a mistake here. Let's go back and fix that. It's supposed to be 252. Because 2 goes into 4 2 times at once. Alright, let's divide this by 2 again since it's still even. 2 goes into 2 once, 2 goes into 5 twice, remainder 1 and 12, 6. 26. Still even, take out the 2, you have 63. Now let's see what we can take out here. Take out a 3, you have 21, and then take out a 3, you're left with 7. Okay, so let's see here. What can we take out? Take out these two 2's as 1. These two 2's can come out as a 2. These two 2's can come out as another 2. These two 2's can come out as a 2. And then these two 3's repeat. So they can also come out as a 2, as a 3. Okay? Alright, so let's put that back in. So we're going to have 2 times 2, 2 times 2 is 4 times 2 is 8. 8 times 3 is 24, so we have 24 on the outside. Square root of 2 times 7, which is 14. Okay? Don't forget the 2 and the 7 do not have a pair to break out with, so they remain as radicands. Okay? Alright, so let's insert that back into the original problem. 24 root 14 as a replacement for the square root of 8,064. So we have, this becomes 24 root 14 over 63. Now, is there a greatest common factor other than one of these two numbers? The answer is yes. 3 goes into both of them. 3 goes into 24 8 times, and 3 goes into 63 21 times. Alright, so this simplifies into 8 root 14 over 21. And there goes your final answer. Okay, that was a simplified form of the square root of 128 divided by 63. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel, and please post a comment to let me know what you think about this clip, and click like if you liked it. More clips can be found on mathclassserve.com. Thanks again for watching, and have a wonderful day.